Hello. Welcome back to the third devlog. I believe this is the third one I'm doing. Yeah, I'm going to continue solving Ziglings exercises. I believe we were on the number 16. The same deal. I'm going to do at least 5 as long as I feel like it. So let's start. Let's build. Yeah. The next one is number 16. For loops also let you use the index of the iteration, a number that counts up with each iteration. To access the index of iteration, specify a second condition as well as a second capture value. Okay. So does this mean we can also start for loop from indexes other than 0? That I'm going to track. You can name item and index anything you want. Yeah, of course. I is a popular shortening of index. Yeah, the item. The item name is often the singular form of the items you are looping through. Okay, yeah. Let's solve the problem. What is the error? Expected type expression found parentheses. Maybe I need to also start my language server. Yeah, that's the error there. Let's store the bits of binary number 1101 in little Indian order. List significant byte or bit first. Okay. Little Indian order, least significant byte order. Okay. Yeah, that's correct. Now we'll convert the binary bits to a number value by adding the value of the place as a power of 2 for each bit. See if you can figure out the missing pieces. So yeah, this is like, hopefully, what I'm doing, and here, what is it called? It's called the bit. The index is I. Yes. Note that we convert the u size I to u32 with at the int cast, a built-in function just like at import. We'll learn about this property properly in a later exercise. That's fine. Yeah, let's see if it solves the problem. Yeah, this is solved. As mentioned in the previous exercise, for loops have gained additional flexibility since these early exercises were written. As we'll see in later exercises, the above syntax for capturing the index is part of a more general ability. Hang in there. Okay, that's cool. And what we did is basically, I want to also learn the logic we have here. So we have 3 bits, and what we want to do, 4 bits. What we want to do is to basically write it from right to left, right? And then we have a for loop on bits. Value is 0. Okay, we have a loop. We start from the first element, which is this. and then have the index. Yeah, and then we turn the index into integer. Const place value. This is mass. This is the power. What is the syntax? Can I see? Go to definition. What was it? Hlog definition. I had something for it. John. Xref definition. Meta. Okay, now I found it. Syntax is return x raised to power of. Okay, that's fine. But what are the values for? Okay, this is the base, this is the power, and this probably is the output type. Okay. Yeah, this is output type because the return is getting the U32 value. U32. So what we are doing here is basically raising 2 to the power of index. Index being 0 here, meaning we get 1 value plus equal place value multiplied by bit. Interesting. So let's see how does it work. I have in this step I have an index. I have value, right? On the step 0, maybe I need to also have and so put bit I and value. And the step really doesn't matter, but here. Okay, for the first bit I have 1. For the index I have 0. The value, so the place value would be 2 to the power of 0 being 1, and then multiplied by bit, it will become 1. Oh, value is something we are adding to, okay? Okay, I'm going to keep the p value over here. P value for the first one was 1. Okay, then the next bit is 0, and then index is 1. P value here would be 2 to the power of 1, 2. And the value will become place value of 2 multiplied by 0 value remains 1. Okay, this is correct so far. We want 1 1 0 1, so these two are checked. Now how it turns to 0. The next bit is 1 and I is 2. Yeah. The I is 2. Place value would be 4. Value plus equal to place value multiplied by bit, which becomes 4. Value. What we are doing here is calculating the value. Okay, I got it wrong. I thought we are printing this, but what we want is 13. So for the next value, we are getting a 4. And yeah, we are basically calculating the little Indian, and this will become 5. Right, and probably for the next iteration, we also have 1. I will be 3. 2 to the power of 3 would be 8. And value plus equal to face value. Yeah, 8 1 is 13. This is checked. Okay, this basically what we are doing here is calculating for each index what would be the value of that index in binary translation, and then yeah. Nice. Going for the next exercise, being 17. Quiz time again. Let's see if you can solve the famous Fizz Buzz. Players take turns to count incrementally, replacing any number divisible by 3 with the word Fizz, and any number divisible by 5 with the word Buzz. There's a Wikipedia page for it. Nice. Let's go from 1 to 16. This has been started for you, but there are some problems. Import a standard library. Nice. So what we do here is add import std, and then the error we have here, yeah, pub fn. This is good. And then what kind of loop we have here? This is a while loop. And if divisible by 3 with if divisible by 5 pause, if not divisible by 3 and 5 Number divisible by 3. Okay, if not divisible by any of those, it should be the number itself. And std should be cuts. Nice. Let's also track it here. 16 sold, 17 sold. Now we are going to 18. Functions. We've already created lots of functions called main. Now let's do something different. Append foo. Yeah. The foo function above takes a number n and returns a number that is larger by 1. Okay. Note the input parameter n and return types are both u8. Good. Please define the deep thought function below. We are just missing a couple of things. One thing we are not missing is the keyword pop, which is not needed here. Yeah, that's understandable. FM, and for now let's put u8 here. Number courtesy of Douglas Adams. Yeah, the Guardians Hitchhiker in Galaxy, not Guardians of Galaxy. Yeah, the function deep thought should return 42. That's fine, I think. Nice. Solved. For number 19. Now let's create a function that takes a parameter. Here's an example that takes 2 parameters. As you can see, parameters are declared just like any other types. Name, colon type, okay? My function number u8 is lucky bull. And then we have the main function, which prints powers of 2. 1, 2, 3, 4. Okay. Okay, now please give this function the correct input parameters. You'll need to figure out the parameter's name and type that we are expecting. The output type has already been specified. So if I come here, it should be my number. And yeah, I think u8 would also work here. I'm just trying to keep it as low as possible, making sure I'm not exceeding this, but power of 2, probably we can calculate it somehow to make sure we are safe. Takes a numeric type and 2 numbers of that type. Okay, this is the documentation I was looking for earlier, looking at code, but that I think I figured out. Now Zig build again. Good. Number 19 also solved. Let's go for 20. Let's see if we can make use of some of the things we've learned so far. We'll create 2 functions. One that contains a for loop and one that contains a while loop. Both of these are simply labeled loop below. Okay. What are we doing here is basically the main function has a list of u16 values, 4 exactly, 4 items, print power of 2, my number, and then std debug print a new line. You won't see this every day, a function that takes an array with exactly 4 u16 numbers. This is not how you would normally pass an array to a function. We'll learn about slices and pointers in a little while. For now, we are using what we know. This function prints but doesn't return anything. So the type here would be void, not void. And then here I would have a for loop. This function bears a striking resemblance to 2 to the in the last exercise, but don't be fooled. This one does the math without the aid of the standard library. So what it does is basically return a number. I'm going to keep it like u32, just same as the previous function we had, and then the loop here would be a while loop, and the return value would be total. So then here it should be delete it, u16. So what it does is basically multiply the number well, is it? It is multiplying the number by 2 for the length of the numbers that are below the number itself. So if you multiply, you pass 2 to it, it would be we have, I'm using this for the number, and then n is 0, and there is a t for total, right? And then I'm passing in, let's pass, what do we have there? 5, right? And then n is 0, multiplied by 2 every time until it's, then it would be to the power of 5. Yeah, this is it. Okay, and then I think I solved this one as well. Okay, this also solved. I'm going to feed my cat and get back for a few more exercises. I'll be right back. Very well. I'm back. And my cat is also happy now. For the next exercise, number 21. Believe it or not, sometimes things go wrong in programs. In Zig, an error is a value. Errors are named so we can identify things that can go wrong. Errors are created in error sets, which are just a collection of named errors. We have the start of an error set, but we are missing the condition too small. Please add it where needed. Okay. Too small. And then here, if number error is equal to my number error too small, okay, so this is called an error set, and then it's just a list of values, curly braces, nothing specific about it, just a keyword error. Okay, and then how does it understand? The errors are returned down here. If a number failed, 2, 4. Okay. This one is free. Okay, super simple. If you have an error, just return the type. It's like an enum. Okay. We build it. Yeah. Problem 21 also solved. A common case for errors is a situation where we are expecting to have a value or something has gone wrong. Take this example. What happens if getText can't find foo.txt? How do we express this in Zig? Zig lets us make what's called an error union, which is a value which could either be a regular value or an error from a set. For now, let's just see if we can try making an error union. Looks like my number will need to either store a number or an error. Can you set the type correctly above? Got it. So it lets us make what's called an error union, which is a value which could either be a regular value or a number. Then here it says my error set, either a value from my error set or a number. So it would be my number or you. Yeah. One way to deal with error unions is to catch any error and replace it with a default value. If can fail fails, who will equal to 6? Oh, you just catch it, you don't. I think this is a super simple one here, but we also need to define the type down here, which is either my number error or the U32. Number 23 also solved. Go for number 24. Using catch to replace an error with a default value is a bit of a blunt instrument, since it doesn't matter what the error is. Catch lets us capture the error value and perform additional actions with this form. Okay, so you can either be more elaborate on how you handle the error, or you just can have a default for it. Okay, and I still have the same my number error pop function. What is the error here? Okay, I have some question mark. The catch 0 below is temporary hack to deal with make just rights returned error union. In this silly example, we will split the responsibility of making a number just right into 4 functions. Okay, make just right is what we are calling here, and then we have another function fix to big, which returns the same error type and number. If it's returning error, we are just returning error, but here fix to big is going to call fix to small, and yeah, if error is too big, return to any, and calling fix to small. So we have a chain of functions, we are passing it through to the lowest one, and only the lowest one is calling detect the problem. Yeah, now I get why it's silly. Now, oh dear, this is missing a lot, but don't worry, it's nearly identical to fix too big above. If we get a too small error, we should return 10. If we get any other errors, we should return that error. So we do catch, and then we have the error, and then curly braces, and then if we get a too small error, so if error is equal to my number too small, return 10, and else just return error itself. It should have this. One thing I'm realizing about Zig is when you read a new piece of code, it looks very verbose, and the syntax only makes sense when you actually write the code. Yeah, this is kind of looks verbose in the beginning if I see it. Yeah, I was feeling the same up here, and then when I wrote it, it just makes sense. Yeah, number 24 also solved. Let's go to 25. Zig has a handy try shortcut with this for these common error handling patterns. Catch error, return error, which can be more compactly written as try. Okay, so try basically returns the value if the value is there. If not, just return the error. It's just unpacking the return value. Okay. What is the problem here though? Invalid operands to binary expression. Okay, here I'm expecting either, okay, go to here and then put try. This should solve the deal. So yeah, the problem was I was adding a value and returning it, but U32, which we can add to, is just part of the return value option. So sometimes it can also contain errors. To solve that, I need to put a try. The disappointing part was ZLS. The language server couldn't show the error, but the type here helped me to figure this out. Okay, that's fine. Number 25 also solved. Let's go to 26. 26. Great news. Now we know enough to understand the real hello world program in Zig, one that uses the system standard library, a standard out resource, which can fail. Okay. Take note that this main definition now returns an exclamation void rather than just void, since there is no specific error type. This means that Zig will infer the error type. This is appropriate in the case of main, but can make a function harder or even impossible to work with recursion in some situation. You can find more information at Ziglang documentation in further error sets. We are going to get back to that, but for the time being, we get a writer for a standard out so we can print it. Okay, stdfs file stdout writer. Unlike stddebug print, the standard out writer can fail with an error. We don't care what the error is. We want to be able to pass it up as a return value of main. We just learned of a single statement which can accomplish this. But do I need to try it though? Yeah, apparently I need to try it, but I'm wondering now that the return type, oh, I'm not returning this. That's why I'm not returning this function, so and I don't know what the return type would be. Okay, 26 also solved. Now to 27. I think this is something I already know. Yeah, you can assign some code to run after a block of code exists. by differing it with a differ statement. Yeah. In the example above, run later will run when the block is finished. So the code above will run in the following order. This feature seems strange, no, not at all, but we'll see how it could be useful. Yeah, I know they are using it mainly for when resources are allocated and you are going to deallocate it uh, before exiting. It's just kind of like how we do it using context managers in Python. Yeah, without changing anything else, please add the first statement to this one, and you should be fine. 27 also sold. Now go to 29. Not 29, it's 28 after 27. Okay, 38. Now that you know how differ works, let's do something more interesting with it. We have a main function, a list of animals. For animals, as a print animal, and a print done at the end. This function is supposed to print an animal name in parentheses, like goat. But we somehow need to print the end parentheses, even though this function can return in 4 different places. But we somehow need to print the end parentheses, even though this function can return in 4 different places. I have a problem with that sentence. I cannot read it. Anyways, but I think I know what's happening here, right? It's not in order, okay? Is to the print. Yeah, this should be the first. Yeah, easy. Another common problem is a block of code that could exist in multiple places due to an error, but that needs to do something before it exists, typically to clean up after itself. Yes. An error differ is a differ that only runs if the block exits with an error. The cleanup function is called only if the try statement returns an error produced by can fail. Okay. Pop and main void, we simply quit the entire program if we fail to get a number. Cache return, we just return. Okay. Make number. Getting a number, please make sure the failed message print only if the make number function. What is it called? Error differ. This could fail. This could also fail. I could fail, but I don't. Yeah, cool. And then I fail after the first time you run me. If counter is 0, we're using the global variable here. Okay. This is, yeah, I have a strange feeling about it. I know it's reasonable to use it in low-level programming, but for many years I was trying to never ever use global variables. Okay, cool. Number 29 also solved. Let's go to 30. The switch statement lets you match the possible values of an expression and perform a different action for each. This switch is equivalent to if else statement. Like, okay, yeah, that I know. Handle all possibilities. There is an else statement. Okay, so we don't need everything in between. Switches must be exhaustive. There must be a match for every possible value. Please add an else statement to this switch to print a question mark when the C is not one of the, well, okay. Where do I have this? Yep. And then a question mark. No, I still have a problem here. Incompatible types void. Oh, I needed to print something, man. Debug dot print. And here, Zig build. Nice, easy. So we are at problem 13, but in the middle of the way, I remember I forgot something here, which was kind of interesting to me to check. So what happens if I start my indexes from numbers other than 0? So let me see what is the run value of this program. Or I do something more stupid. I do for loop here, and then bits. I want to do 1, and for this I, and then print print I zig run. Oh, this is not the index. This is from what number it starts to. Actually, let's me to also add another print here, and put a /n. Yeah, this is the start number, what the index is called, and by default we are using 0. Okay, I thought it's going to skip that number. It's like enumerate in Python, where you can define the starting point of the count. Okay, cool. That I needed to know. Cool. Thanks for watching. If you like, please subscribe this channel. I'm going to try to do these streams more regularly. I'm planning to also release some shorts for each exercise that I'm solving here, so probably easier to iterate over. Please feel free to engage, leave comments if you like, and yeah,